Okay, now we're going to do hypothesis tests for difference in proportions. So participants in a study to evaluate accuracy of lie detectors were divided into two groups. One group read true material while the other group read false material while connected to a lie detector. Both groups received electric shocks to add stress. The two-way table indicates whether the participants were lying or telling the truth, and also whether the lie detector indicated they were lying or not. So are the conditions met for using a normal distribution? Yes, all cells are at least 10. So find the three sample proportions for the proportion of times the lie detector says the person is lying, the proportion for the lying people, the proportion for the truthful people, and the pooled proportion. So the proportion for the lying people, so detector says they're lying, so that's 31 out of the total of 48 people who lied, which is 0.6459. So the proportion of those not lying, so 27 out of the 48 who were not lying were told they were lying. So that's 0.5625. Now the pooled proportion is p hat, which is 31 plus 27 over 48 plus 48, which is 0.6042. Now, test to see if there is a difference in the proportion of times the lie detector says the person is lying, depending on whether or not the person is lying or telling the truth. So the first one, HO, is that the proportion lying is equal to the proportion not lying. And then HA would be that they're not equal, or the proportion of those identified as lying who actually lied, and the proportion identified as lying who did not lie. So now we have to define the parameters. So PL is the proportion identified as lying who did lie, and P sub n is the proportion identified as lying who told the truth. We don't have to check conditions because we did that previously. So the test statistic is Z is the statistic minus the null over the standard error, which is P hat sub L minus P hat sub N minus 0, because we want them to be equal, so the difference is 0, over the square root P hat times 1 minus P hat over the number lying plus P hat times 1 minus p hat over the number not lying. Remember, for this, we have to use the pooled proportion. So our numbers, we have 0.6488 minus 0.5625. We don't have to include the minus 0. Over the square root of the pooled proportion is 0.6042. So we have 0.6042 times 1 minus 0.6042 over 48, and 0.6042 times 1 minus 0.6042 over 48. In this case, both sample sizes are the same. So this turns out to be 0.0833 over. So we have 0.6042 times 1 minus 0.6042 divided by 48 plus 0.6042 times 1 minus 0.6042 divided by 48. Then take the square root of it. We get 0.0865. So we have 0.0833 divided by 0.0865, which gives us 0.9630. Now in step 3, we get the p-value. It's a not equal, so it's a two-tail. So it's 2 times normal CDF. Since the test statistic is positive, it's the lower limit, 9630 and 999. So we have 2 times normal CDF, 0.9630, 999, and we get 0.3355. So since p-value is not less than any reasonable significance level, we do not reject H sub 0 and conclude that there is not sufficient evidence to say that a lie detector can tell whether a person is lying or telling the truth.